you just don't like, and you're like, oh.
You never even met them before.
What?
You say you never even met them before.
I know this from past experience. So I learned, no, if I can avoid it, just avoid it. Because then they put you in pairs, and then you have to work with someone you don't like. You see, this is why I don't put you in pairs, because I know if I was asked to do this, it would annoy me, because I would be paired up with someone maybe I don't like, that annoys me.
Yes. In pairs for experiments.
I know, but that's only because I don't have money to buy more equipment. I know, they're very cheap. They're very cheap. No, they wouldn't. They barely pay me enough money to live, so... those chocolate eggs really took a lot out of me.
Thank you.
It's okay. Sacrifice. You were worth the sacrifice that had to be made. Okay, so electromagnetic waves next.
Teacher that's studying PhD in Trinity.
Correct. Yes. For which subject now? Because we have two. Yes. There's an English teacher who's doing a PhD in Trinity, and the new chemistry teacher as well. Is it? Yes. Huh? No, the pay is the same for all the teachers.
No, I mean like CSC must be paying well if they come.
You have it so backwards. So
Irish people don't have to pay enough to go to Trinity, do they?
not as much as they should. It's subsidised by the government.
No, but like it's not more than 5,000.
Yeah, something like this. Yeah, and the problem is, because education is cheap here for Irish people, it means many people have a PhD. So
no competition.
you're thinking, oh, we must be paying so well that we attracted someone with a PhD. Instead, you should be thinking, oh, this person could only find one open position.
Because if I want to go to Trinity, I have to pay more than 25.
Yes.
Unfair.
It is unfair, but I'm not complaining, because Trinity is where I studied, so I benefited from it. All the maths teachers at the school graduated from Trinity College. The maths teachers. Yeah. Ivan, Joan, me, we accept only the best for maths. Nothing else will do. Our students deserve the best maths education they can get. Huh?
Why don't you teach us maths for semester?
I can only have you for 5 or 6 hours a week, and then I start to feel sick.
So nice of you.
No, it's not personal. It's because I'm so overworked. I couldn't work anymore. It's not personal. It's not you. Trust me. Okay, you got this electromagnetic waves. No, don't. You're taking this personally. You shouldn't. Electromagnetic waves. You have this? Yeah.
Trinity is known for law, right?
Many things, but law would be one of them for sure. Yeah, and languages as well, and languages in law. So they're excellent at French and law, this combination. And it's very difficult to get into because there's only like 4 places. So if you want to have a degree in French and law, you're competing with 4 other people in the country. So, okay, so let's have a look here at light. So light is actually a very special type of wave. And it's an example of an electromagnetic wave. Now, what's so great about these electromagnetic waves? Well, here are more examples of electromagnetic waves. So, a radio wave is an electromagnetic wave. Wi-Fi is electromagnetic. Mobile phone, the wave that comes off here and connects to the tower, that's electromagnetic. X-ray, electromagnetic. Your remote control for the TV, that's electromagnetic. And what's actually amazing about all these types of waves is they're actually all the same thing. What I mean by that is the only difference between this and this, and the only difference between this and this, is the frequency. That's all. So in fact, all of these are the same. They only differ by their frequency. So if you had a radio wave and you could increase the frequency, you could turn it into an X-ray. Or likewise, if you had an X-ray and you could decrease the frequency, you would turn it into a Wi-Fi. That they're all the same, that they only differ by frequency.
So they have the same speed?
Yes, exactly. So they all have the same speed, which is the speed of light.
What's the difference between them and the transceiver and longevity?
Yeah, an electromagnetic wave is just the name of this family of things.
Then there are 3 types of waves?
No, there's 2. Transverse and longitudinal.
Then
It's like electromagnetic is like if I said a sound wave. Like a sound wave isn't a different type of wave. A sound wave is an example of a longitudinal wave. Just like an electromagnetic wave is an example of a transverse wave. Yeah.
Then transceiver wave,
Yeah.
longitudinal wave,
Yeah.
electromagnetic wave.
Yeah. It's like you have transverse
Yeah.
and you have electromagnetic. You have like guitar strings. Like this. And then you have longitudinal, and you have things like sound wave and earthquake waves underground. So there's 2 main branches of waves. Electromagnetic is a transverse wave, but it's very special because all these things are the same. They only differ by frequency. That's all. So, for example, a sound wave. What is the difference in a sound wave when the frequency is different? You can hear the difference. The pitch, yeah. Like a singer singing at different frequencies. It's kind of the same thing here. If I change the frequency of the light, it sounds like or becomes like an X-ray. It's the only difference. So, these are all electromagnetic waves, and we can put them on what's called an electromagnetic wave spectrum. So, low frequency are waves like this: radio, microwave, infrared. And then high frequency are ultraviolet, X-ray, gamma. And in the middle we consider the visible light as in the middle between low frequency and high frequency. Now, there's something interesting happening here as well. We have the formula V equals lambda F. But V is a constant, it's the speed of light. What letter do we use for that? C, yeah. Because this is constant, it means an increase in the frequency would mean a decrease in the wavelength. So they have this opposite relationship. So as the frequency is low, the wavelength is long, and when the frequency is high, the wavelength is short. Yeah. Now, this you need to know for the exam, because they sometimes ask students to draw out this spectrum. So if you can copy this in. Now look, you don't need to draw the pictures, okay? Just write the names down, that's fine.
Do we need to draw like the wavelength getting smaller?
Yeah, you should, yeah, if you can try your best.
Even during the exam?
In the exam they don't usually care, but I could easily imagine them asking you to do this as well.
You have to know the name of the product.
Yes? Yeah.
What's that?
Which one?
Ultraviolet.
Ah, you know ultraviolet? UV?
UV?
From the sun. Oh, I saw the former South Korean leaders in prison now. 27 years?
27?
Right? 24 years? 20-something years for sure, yeah. You know who I'm talking about. the leader, the woman in South Korea who's in prison.
Ah, yeah.
The last one, yeah.
That word. And the girl is in jail
Yes.
now, and the previous president is jail too.
The previous as well.
Yeah. Oh wow.
Oh, I see. It's a tradition.
Yeah, tradition.
Tradition.
There's some stats.
Yeah. First, you're the leader of South
Leader
Korea, and then prison.
Yeah.
Yeah.
Top to the bottom.
Yeah.
Yeah.
Press the trough.
Yeah.
Yes. Yeah. Okay. Very good. Yeah.
That means all of our previous presidents die or in jail.
Those are your choices.
Yeah.
Tough choice.
Die or in jail.
Yes. Okay.
There are no choice.
Okay. That's not good then. Okay, so I remind you that in the exam, they do want you to know where these items are, the order. They do ask this in the exam. Sometimes they give you the items and they ask you to put them in order.
Oh, that's good.
That's better, yeah. By the way, where would Wi-Fi be? Does anybody know? Wi-Fi?
There.
Oh, there!
Between microwave and infrared.
Between microwave and infrared, good. Any other guesses? Or you agree between microwave and infrared? Yeah. Wi-Fi is actually exactly the same as microwave.
Same microwave.
Same frequency as microwave.
What's the difference between the 4G and 5G, 3G, 4G?
That's different now because that's not Wi-Fi. Okay, that's a mobile phone.
Ah, yeah.
A mobile phone is not where microwave is. Mobile phone is between radio and microwave. And I believe, now I'm not sure, but I believe the difference between 3G and 4G and all of these, they might be different frequencies within a sort of a band here. Now I don't know. I am guessing that the 3G and the 4G, these are frequencies which are, you see, in countries like Ireland and America, you can't use any frequency. You have to get a special license. Do you know what I mean? So you couldn't just open up a telephone company and use any frequency. You have to get permission to use that frequency. So I think what happens is 3G and 4G are just frequencies which are locked that you can't use, and then the government releases them. And the reason you would want to do this is it means that if nobody else is using this frequency, then you can broadcast and not have any interference. You know, like if you think about a radio station, if you broadcast on the same frequency as the radio station, you could interfere with it. You know, you can get little machines that broadcast radio waves, and you could change what your neighbour hears if they're listening to the radio. You can't do this with 4G because you need a special permission to do this. So mobile phone would be here, and Wi-Fi would be exactly here. Now, there's a little experiment you can do at home. I don't recommend you do this at home, but if you do this experiment at home, please unplug the microwave. Okay, so make sure the microwave is unplugged and off, and it cannot turn on. So what you do is you take your smartphone and you look at the signal, and you can see, the bars for the mobile network like Vodafone, and then you can also see the bars for the Wi-Fi. So you have two bars, the mobile phone and the Wi-Fi. You put this in the microwave, if it's off, you close the door, and what you'll see is that the Wi-Fi will disappear because the door on the microwave blocks that frequency. So the Wi-Fi signal bounces, it can't get back in or out. But because the mobile phone is on a different frequency, it can travel through the door and you can still actually make calls, but you can't use the Wi-Fi.
How could I check the extension?
Well, just put the phone near the door so you can look in, and then you can see the bars. Huh? Well, if you want to turn the microwave on with your phone in it, you can see what happens. I think I know what would happen.
Nothing happened, right?
Oh no.
What?
No more phone.
Yeah. Oh my God.
Yeah. You're going to ruin your iPhone.
And your microwave.
The microwave might be okay actually if you turn it off quickly enough. The phone will definitely be gone.
The microwave is Wi-Fi.
Not even this. Huh?
But microwave is Wi-Fi.
Correct. But the energy from it is really, really large. So although it's just Wi-Fi, it's kind of like it's like sound. Okay, sound is obviously not damaging, but if you make the speakers loud enough, it is damaging. So even though it's only Wi-Fi, it doesn't matter. If it's only whatever, if you have enough of it hitting the phone, it'll damage it. Just like sound, enough sound will damage your ears. It doesn't matter what the frequency is, you know. So the Wi-Fi will not work, but the mobile phone signal will still work. Yeah, I think that's interesting. It's something you can do at home then. Okay, did you copy this? Now we need to look at visible, because with the visible, you can actually expand it, and you can actually see that the different colors represent different wavelengths. So the one with the biggest wavelength is the red colors. They have 700 nanometers. And then down here, the purples, their wavelengths are 400 nanometers. And again, you do need to know these numbers. They do expect you to know that 400 nanometers is purple, 500 is this turquoise, 600 is this yellow-orange band, and 700 is the red-orange. So for example, the question might be, what colour is 750 nanometers? And if you say red or orange or reddy orange, they'll give you the marks. But if you say yellow, well, that's clearly wrong. Green's around about here, about 550 nanometers. You should know what red, the ones I've seen, red, green, blue, yellow. Yeah, you should know the rainbow. Red, orange, yellow, green, blue, and purple. No, pink is okay.
Red, brown?
Yeah, no, these are okay. You just need to know 6. Red, orange, yellow, green, blue, and purple.
But there are 4.
Yeah, so like red is 700 to 800. Green is near 550. Orange is about 650. Yellow is 600. Blue is 450. 500. Okay, 5. And purple is around about the 400. Yeah, 4 times 10 to the minus 7, which is 400 nanometers, yeah?
Why isn't there something between purple and the blue?
There's 2 colours, but they don't expect students to know I don't know the difference between the 2, indigo and violet. I just call both of them purple. Like, I call this purple, even though it's probably not something other than purple, I don't know. Yeah, me too. You got these colors? Yeah, this is 400 nanometers, 500 nanometers, 600 nanometers, 700 nanometers.
what do you call it for orange? Oh, what is it?
650. Yeah.
FM and AM have different frequencies.
Yeah, but the difference between FM and AM is actually not really the frequency, but how the wave is transmitted. AM, the AM waves, the amplitude keeps changing. So the wave that comes out of the AM tower, the amplitude changes because the voices change, so they need to change the wave for the different voices. The FM, what they do is they keep changing the frequency. It's a little bit complicated, but the difference between AM and FM is really just how they transmit the wave. So the AM, they keep changing the amplitude to produce the signal, and for the FM, they keep changing the frequency to produce the signal. Okay, continue. You have these colors? Yeah. So, there are at least three important things about electromagnetic waves. Firstly, they're transverse. Before continuing, they sometimes ask this in the exam. They might say, list three things important or three properties of electromagnetic waves. So one property is that they're always transverse. The second property is when they travel in a vacuum, they travel at the speed of light, which is roughly this. And lastly, most interesting, that they need no medium of propagation. This is quite strange if you really think about it. If I have a sound wave, the sound must travel in the air. Okay? If I have an earthquake, the wave must travel in the ground. If I have a musical instrument, the wave must move in the string. But electromagnetic waves, they don't need a medium. They can travel in a vacuum, which makes you think, what is vibrating? If there is a vacuum and the wave is moving in the vacuum, then what is the thing that is vibrating?
No vibration.
Yeah, but it's a wave, so something's vibrating.
Oh yeah.
Yeah, but even between themselves, like what is it that is vibrating? You know?
Wow.
Yeah, but what? What is going up and down?
Oh, the matter of the.
Yeah, but what is that thing? What is the thing that is vibrating when it's moving in a vacuum?
Oh, nothing.
But it has to be something.
So we could have Wi-Fi.
Something is nothing.
Yes.
Something is nothing.
In fact, it would work better in space. Because the reason Wi-Fi doesn't work well at home is because of walls and things like this. The answer will be coming up later this semester.
Later.
Yeah, in the last chapter.
Of this.
No, of the semester, yes.
So should we?
But the key point is, it doesn't need a material. It can travel in a vacuum. That's the key.
Can travel.
In a vacuum. You can't do this with sound. You can't do this with an earthquake. You can do this with light and radio. It's a very strange property. Yeah. So it seems like it's unlimited. It can move through any material, even no material.
That means you and me are in the outside of the earth.
Yeah.
We can talk about anything.
Using like Wi-Fi?
No, just Face to face.
No, we can't. Because there's no...
Voice.
Yeah, exactly. The voice can't because there's no air. Yeah.
Oh my god, then what's this? You you can speak, but I can listen.
No. If we were in space and I talked, you couldn't hear anything. However, if I took out my phone, I could send you a text message. Because the wave could travel to your phone, but I couldn't speak.
Oh my god.
Light travel.
Light, yeah. Light travels in space, in a vacuum, yeah. Okay. Continuing. So, because V always equals C, then we can actually say V equals C equals lambda F, which I said earlier. So it means that if I know the F, I can know the lambda, and vice versa. If I know the lambda, I can know the F. And lambda is C over F, and F is C over lambda. So if the F is bigger, the lambda is smaller. If the lambda is bigger, the F is smaller. So big wavelength means small frequency, and big frequency means small wavelength for electromagnetic. But we talked about that already. So now, polarization. Does anybody know this term?
This.
What is that?
What's this?
So,
Yeah. Anti.
no, actually, although it's the same word, it's not to do with poles like that.
Dipole.
No, not to do with dipole or poles. No, we don't know this one. So, polarization of light or other transverse waves is when the vibrations are confined to a single plane called the polarization plane. I'll explain this with a picture. So what happens with the light that comes from the sun, it's transverse. But it's actually many transverse waves in many directions. So some will move up and down, some will move left and right, some will move at an angle. This polarizer, when the light hits it, only the light vibrating vertically will travel through. Everything else gets blocked. So what you do is, maybe you have 1,000 light waves, but only the one that is traveling vertical will travel through the polarizer. Now actually, there is something that you might have, especially the Middle Eastern students. There's something that you should have, especially when you're back home, that uses this technology.
Polarized sunglasses.
Exactly right, yeah, the polarized sunglasses.
Ray-Ban.
So these expensive sunglasses, they block most of the light and let only a slice of the light in. So these polarized sunglasses are exactly this. It's just a filter, yeah, with just lots of vertical slits. Do you have these with you here?
I don't have them back home.
Oh, okay.
I just don't.
Okay, why not? Why not? Do you have them? Ah, I thought you're Middle Eastern, right? You don't have polarized sunglasses, and yet...
There's like some things they put on cars.
No, that's actually, that's like the cheap sunglasses. They don't polarize. I think that's just like a dye, like it's coloured.
No, it's on the windshield.
Do they place it on it?
It's like a stick.
The sticker thing that they stick on it? Yeah, I don't think that's a polarizer. I think that's just like a dye. Plastic that's dyed black. It's not actually polarizing the light, I think.
The one you put in the car with the small hole.
Which one's this? Oh! The little black dots, is it? That's not a polarizer, that's just to block some of the light. In fact, they do that so that it doesn't get too hot around the edge of the window because the rubber would melt. I imagine especially in Dubai, if you leave your car out in the car park, yes, it will get very hot around the window. Nobody has these polarized sunglasses? Nobody.
I have.
Now the real polarized sunglasses are the cheap
Not
ones.
cheap, Gucci.
Okay, have you got them with you
Huh?
in Ireland?
No, Korea.
Okay, so these are actually good for your eyes because they do stop most of the light. The cheap sunglasses, they don't block the light. They really just change the colour of it to black. It's not the same. It's not the same effect. So, please try to draw this. It'll be difficult.
Draw this?
Yes.
Oh my god.
Yes.
Untied?
Huh?
Untied.
I don't. Come on.
What's wrong with you?
Come on. If you had two pairs of these sunglasses, and if you were to take them and place them on top of each other, but turn one of them sideways, it'd be completely black, because you would block all the vertical light and all the horizontal light, so no light can actually pass through the two lenses. So if you had two of these sunglasses and just turn one sideways, it should be completely black. You can't see anything through it. By the way, this is actually how some of the 3D glasses work as well. Some of the light from the projector is moving horizontally, and some of the light is moving vertically. And this lens would be vertical, and this lens would be horizontal. So when the light reaches your eyes, only the vertical goes into this one, and the horizontal goes into this one, so you can have two different images. Huh? The point I'm trying to make is, although this is very simple technology, it can actually be really, really useful. That's why you're learning about it. What the heck is that? That's
Polarization. Polarization.
Oh, okay.
There are no polarization glasses in art.
There's not a need for it.
Okay, something.
Yeah.
Sometimes.
I think I need this most when they drive, like when my parents drive.
Driving, yeah. Especially now, when the sun reflects off the sand. There's no sand in Dubai. It's just green fields of cows and lambs and sheep, is it?
Crown.
Yeah, but
Like, there's no sand, like, it's not a desert anymore.
there's no sand in
No,
Dubai.
In the desert there is.
Yeah.
Yeah, but
So like say I'm driving through the desert.
Oh,
So I'm in the
yeah.
city and I said I'd like to see a cactus and a camel, so I'll drive through the desert.
Yeah.
I'll see sand then, I would
Yeah.
hope. Yes, I do.
But like in the city they also need it.
Yeah.
Maybe because the ground is
Just like in Ireland, there's no cows in the city, but there are cows in the fields outside the city. I imagine there are no camels in the sea in Dubai. Yeah. You know camel?
Like
Usually two.
Yeah.
Usually. No, they're ugly.
No.
They're ugly.
Cute.
They spit at you and they're grumpy.
Have huge mouth.
Huge man. No, they're ugly. Ugly. Cute camel?
Yeah.
Cute camel?
The baby camel.
You're mistaken. Alright, did you draw this?
Yeah.
You don't think they're cute, do you?
No.
Do you? Okay.
Baby.
Yeah, I haven't ever seen a baby camel, so maybe baby camel are cute, I don't know. Okay, drawn this? Yeah. Continue?
Yeah.
Yeah. Okay, so you might have these if you have sunglasses, which we talked about. What is the frequency of red light if the wavelength is 700? This should take you 10 seconds to do. Can you give me the frequency, please? The wavelength is 700 nanometers. What's the speed? 3 times 10 to the 8, yeah. Don't want to calculate? Too hungry?
Yeah.
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 Hang on, I have one student who bothered to calculate. What is it?
1.28
Yeah?
times 10 to 40.
Sounds about right. What's the unit for frequency? Hertz. Hertz, yeah. Alright, easy peasy, there you go. And you should get these finished before going home, and then no homework. Lucky for you. So let me just up